All right, let's talk about functions. So this is going to follow the process of a function from being just source code all the way through to it being deployed and running as a service. We're going to start with a demonstration, see what's happening, and then we're going to do an explanation how it did this, and finally get into the implementation details. Let's make a new directory for our project. We'll call it www because that'll probably be the name of our module. And it's in the bosonproject.org directory. And let's take a look at what we're going to try to do first. So, or what our primary goal is. We want bosonproject.org to come up. We can use a HTTPS as a little helper to get some more metadata about it. And as you can see, it's not found. So let's take a look at our cluster. It is a 4-node Pi cluster, and it has not really anything running on it. And one quick point here is, in order to follow along with what I'll be showing in this video, there's a few environment variables I'm going to set. The host builder is currently behind a feature flag, so I need to do func enable host builder, and then I'm going to set my default builder to that host builder, and then I'm also going to set the default for running to be to run using the host as well. So these things hopefully will be the default at some point in the future, and the enable host builder will just go away. But for right now, at the time of this recording, you need to have those set if you want to follow along. So now I'm creating a Go function in that directory, and I'm gonna remove the template files that it creates, because frankly I just want to make one from scratch. So maybe we'll add this as a flag in the future, func init --bear or template is equals none or something like that. But for now I just want to remove everything, and just so that we have func.yaml. Okay, so we've got one file, func.yaml. I'm going to go ahead and I should probably change this name. So let's give it a really clear name. You'll note that we have to use only alphanumeric and dashes because it has to be a valid DNS label. So I'll just do func www.bosonproject.org. Right, now the first thing we're going to do is do a go mod init after we've created our function, and that will create the module. It's going to be bosonproject.org/www by default. And now let's go ahead and create ourselves our function. So yeah, we package www, and we're going to make a static function first. This is probably what you've seen before if you've used functions up until this point. We've been supporting package static handlers, and I always get that wrong. And there we go. All right, now we're going to do basically the simplest possible function, which is, of course, a hello world. Okay, so it built. Everything's fine, and you'll notice there are no external dependencies other than the standard library. Let's go ahead and run this locally, make sure everything works the way we would expect. So I'm going to split the screen. So the top is where our function is, and we're going to run it, and the bottom will actually invoke it. Okay, so I've got it on pretty high levels of debug right now, so you're going to see a lot of text messages, and the CLI output is going to be a little bit messy, but we're working on that. Please forgive the dust. It's under construction. So bottom one is where we're going to invoke it. So I'm going to do invoke localhost port 8080. I'll just curl to make it really clear what's going on here. Okay, hello world. Now, if I use HTTP, get some extra metadata, you'll see that everything's fine. We're not going anywhere. It's that local one. So what it did there is it exposed that function as an HTTP service on port 8080 without there needing to be any import statements or anything like that. It's just a pure function, and we'll talk more about that later. Now let's go ahead and deploy that to the cluster. Okay, so it built a couple of different variants, pushed it out to the cluster. And let's curl and see if it's there. Ta-da. Now, what just happened there? You'll see that from that HTTP request, it's going through Cloudflare. I've got this set up to route requests to my Pi cluster. I'm going to go ahead and create a little logs function. It would be really nice to have this in func at some point. That's just going to pull the logs for that container. And let's take a look at it running here. So there it is. It's running. This is the pod it created, and it is going to go ahead and scale down automatically if we wait long enough. What happened here is that it took that function, it wrapped it up in a main file in a service with some middleware. It containerized that, putting everything it needs in there, any static files. We don't have any static files in this one, and pushed that to a container registry, which was running inside of the cluster, and then used the Knative API to deploy that as a service. Okay, so there it went away. Let's see, there's a little bit of a cold start. Container creating. There we go. It's back again. So that's Knative serving in action for you. All right, let's go ahead and talk about this handler for a second. So this is a packet static handler, which is great for really small things, but it quickly is something you're going to outgrow because it has some important drawbacks. One of the most important being, what if your function has a large memory footprint? Let's say it needs to load an MLAI inference model, or it has an internal cache, or it needs to make some slow external requests to get started. It does not make sense to, of course, redo that for every request that comes in. So your only option is to use global variables. And as we know, global variables are fraught with peril. It makes a lot of things more difficult, not least of which being testing, because then, which test is using the global variables, etc. It also means that your function can't be included in other projects as a module, because then you only have one memory space you're working with. So there's a lot of problems here, and this is why we have instances. This is why we have structures to handle this. So what would be nice is if we had the ability to actually instantiate our function. Just like we're creating an instance of a process in the cluster, we want to have an instance of the function. That way we can have members in there. We can have it be reentrant and have a local ephemeral cache. So we can change this to be a structure with a method with a structure pointer receiver. And all we need to do is to export a function named new. And all that new needs to do is return a pointer to a structure which itself implements one of several interfaces. This one would be the request handler. Let's go ahead and deploy this as an instanced function. Let's see, okay, we're running it. Now, look, if I go take a look at it, see, it's an instance. So it figured out it should create an instance of the function and invoke that rather than look for a package static handle method. And pushing it to the cluster, we'll see that that should do the exact same thing. There, container creating. And there we go. I'm an instance now. Now, not only does this make the aforementioned issues go away, that also means that we can do more advanced event handling. And I don't mean events as in HTTP events. I mean like on start, on stop, readiness, liveness. So by default, when you deploy a function to the cluster, you will get a default readiness and handler endpoint that as long as the process is running, it will say, yep, I'm ready, I'm alive, everything's fine. But especially for things which have some startup time, etc., you might want to actually implement your own logic for liveness and readiness. So here's an example of doing that. If you implement alive, you can return yes or no or an error if you can't, if there's some problem, determining it, and the middleware will respond for you to the readiness and liveness endpoints with that information. Now, of course, you can completely override this in your func.yaml if you want, just not use this functionality at all, or start it up on your own, endpoint. That's fine. But this is a friendly way to do it in code. I always forget the T. There we go. All right, so let's deploy this function, which now implements three interfaces. It's a readiness handler, a liveness handler, and an event handler. And take a look at its logs. I've got that little function, which we'll be able to pull up its logs. All right, we're going to deploy. It's creating a new revision. It's deployed. Now let's take a look at its logs. As you can see, it started up and it is noting that it is having its readiness and liveness checked by the underlying infrastructure. The other ones that are currently available in this way are start and stop. So you can implement start, stop, ready, liveness, and handle. All right, let's take a look at the Go mod. Now, one thing to note and remember here is that this module has no dependencies. If this were a cloud events handler, obviously you'd have to have some cloud event stuff, but there's nothing pointing to the infrastructure. You don't have to import some func library and then call start me. And that's important because now our function could be versioned right now. We could say this is version 1.0. We could deploy that. And if the underlying infrastructure changes for whatever reason, we need security patches or new features, all that would have to happen is the function just need to be restarted. Because the underlying system would, wrap it in the process, create a container, and deploy it. The function implementation itself stays the same. Okay, so that was what it's doing from a usage perspective. Now let's explain kind of conceptually real quickly here, like what really happened, and then we'll get into how it did that. So we started with a function, and this could be any function, but we do have a few specific method signatures that we support. In our case, we used one which handles an event and returns a response. By default, all of the functions that are included echo the request they received. So that if you just create a function and then immediately deploy it, you should expect to be able to invoke it and receive a response, which is just an echo of your request. Now, as you notice, that function didn't have any import statements or any dependencies or even a main file for that matter. It is just a pure function. It could be used as a module in any larger system. It could be composed. It's just a module. So in order for that to run as a service on the network, of course, it has to become a service. So it needs to be wrapped in a process boundary. So this is a process we call scaffolding. And what it does is it wraps the function in a service. It gives it a main file. It invokes it and when requests come in and returns the responses. Importantly, it doesn't put a layer in between the requests and responses. It just kind of delegates control completely. Now, once we have this process, then our function is starting to look more like something we would expect from a deployed service, but it's not complete yet. It also needs, configuration, static files, things like that. So this is, of course, wrapped in something we can deploy, code, files, and configuration. That is, of course, the container. And once we have this container, it's pretty much an artifact that most tooling understands how to handle. That's what gets things deployed. There are no dependencies from the function out to the process or the process out to the container. The dependency arrow points the other way. That's the explanation of what's going on. Let's go through how this is implemented. Okay, so there's really a few major steps here. There's the scaffolding, building, deploying, and running. Scaffolding was that process where the function is wrapped in a process boundary, given a main file, etc. And then building is when that's put into a container along with various configuration like static environment variables, expected volume amounts, that sort of thing. And then deploying is sending that container to a registry, whether that registry is inside the container or public, whatever, or inside the cluster or a public registry, whatever, and then contacting the cluster and creating a new service which uses that container, or updating the service to have a new revision. And finally, running is what happens at runtime. The requests come in, the scaffolding code, which is written, which has an HTTP server running, receives a request and delegates it to the function. And not just regular requests, it'll also do things like the liveness and readiness probes, etc. So what happens when we run func deploy? Well, the very first step is it needs to detect the method signature. But how does it get from the CLI to detecting the method signature? Well, there's a short little call stack here. So the first thing is that there's a function called run deploy, and it is in the command deploy.go. Now, this slide is going to be a high-level overview of how the calls are structured so you can get a general idea of what's happening. It's intended to be more something you'd come back and pause if you want to walk through the code yourself to get an understanding of how things are structured, especially in a situation where you might want to help us implement this for other languages. So we're just going to run through this. It's going to say what the key functions are that are invoked and where those functions are located, and you can use it for your reference. So going back here, we've got run deploy is in the command. That's the thing that actually kicks the ball off. And what it does is it creates a new instance of the client, and then it calls the individual steps on that client. The client, the functions client, just provides very atomic, composable little steps. Like I want to build, I want to push, I want to deploy. And the CLI, or who's the one using it in this case, is the one that ties it together based off of flags, etc. So the first one that does is build. Now the client's build, the client is a little bit general purpose. It does the higher level logic, but it doesn't actually have the builder implementation, because you can have different types of builders. You can have pack or S2I. In the case of the demos that we've seen here, it is the built-in host builder. So it's the OCI embedded builder, and that's defined over in the OCI package. So you see here that the OCI builder is the one that implements .build. And when you call that, the very first thing that it does is use the scaffolding package to write the main file, or that process wrapper, into the .func directory. And reminder that that .func directory in your function is not source controlled, it's ignored, and it's for this kind of runtime, locally specific data. Now what that does is it needs to detect the method signature. It needs to know which shape of scaffolding to write. And it already knows that we're a go function because that's, defined. And then it runs detect, and it figures out from detecting that, oh, this is an instanced function and it's HTTP. So I know I need to write the main file that expects your function to be an HTTP request response handler that uses a constructor, right? Now, once it's got that, it can actually write the scaffolding code. So the way it does that is it uses that detected method signature, and it looks in the templates go scaffolding directory. So you might be aware already that the func binary includes embedded in it, the library I should say, templates, function templates for all the different languages. There is a special directory name called scaffolding, which isn't considered a template. It's the stuff that wraps those templates. So if you were to go in there and look, you'd see that there's an instanced HTTP, a static HTTP, an instance cloud events, and a static cloud events wrapper. And you can run tests on those, you can build them, and they will build the templates that they point to. So what this does is it figures out which one of those you need for your function, grabs it, and copies it into that .func directory. Once it has that written, it's a process now. Your function now has a main file. Now that main file is generated on each build, but it is going to, that main file, when you run your program, is going to import your function as a library. It's going to start an HTTP server, and it's going to invoke it. So we need to build this and turn it into a container. So the first thing it does is create a shared static files layer, which is all of the code from your function. That's the source code, that's the static files, etc., unless it's been explicitly ignored. Things like the .git directory or the .func directory are explicitly ignored. You can also add more ignores in the .func ignore file, just like a git ignore, so that you don't send those things off in your container. And that is called via containerize. So this is the builder. Again, this is the second step that the builder is taking in order to build this function. First is write in the scaffolding. Second is containerize it. So the containerize, which is defined in the containerize.go file right now, creates this new data layer. Now this data layer is a file system layer in the resultant container that is shared for each one of the different platforms that the container will contain. Because this is, it's not platform specific, right? The next one is it has to make these platform specific layers. This is important for Go or compiled languages because they have to be cross-compiled. It's not as important for interpreted languages. So it gets the correct layer builder. Again, we know it's Go, so we know which layer builder to get. It calls new image, and that is over in the containerized Go package because now it knows I'm containerizing the specific language. And so for each one of the OS platform combinations which have been chosen, it will run Go build with that cross compilation, tar it up, create a descriptor, and stick it in the container. So the container is now a multi-architecture container because it's like a container of containers, right? That container is then pushed to the registry they've chosen. It uses keychain or username password, and this is using client.push. Now, client can also have different implementations of its pusher. So this is the built-in host or OCI pusher. There's also, a Docker pusher. After that has been pushed to the registry, the cluster is contacted to create a new service or a revision to that service. And this uses client.deploy. And that, again, has different implementations you can choose. I think the only one we have right now is the Knative deployer, which creates or updates the service. Once it's running, then it's the middleware that was imported in that scaffolding code that is going to instantiate and invoke the function on requests. And that's how we get to all the way down to, curling. So we can now take a look quickly at the scaffolding code itself, which I don't think we've looked at yet. So here is the scaffolding as it is built each time deploy is run. And you'll see here, this is the library it imports, which exposes the function as a service. Let's take a quick look again at what it built. You'll see that there is a symbolic link up a few directories to the function source code. It builds, once it's created the function, it builds the OCI container along with a few different binaries. But what we're looking at right now is the main file that it builds. And as you can see, it's an instance handler, so it calls f.new and then passes that to the HTTP start method. And that HTTP start method is in the funcgo repository. It will invoke the methods on the function depending on what interfaces it implements. What we have available is, of course, your standard handler interface, which handles an HTTP request, but it also has starting, stopping, and overrides for the readiness and liveness endpoints. So we can take a look at those as kind of an example of how that works. Here is the keys. When a readiness request comes in, it says, is the function a readiness reporter? If so, it delegates, and otherwise it just returns, yes, I'm fine. So let's review here. We have our function, which is self-contained. It could just as easily be a module as a service, but we want to expose it as a service. So on deploy, actually during the build step, we autogen a service, which then imports the function as a dependency. Now, when a request comes in, or any event happens for that matter, the service then invokes the function if the function has implemented that interface and wants to handle those events. Now, this is an important distinction between what's generated and which direction the arrows point, because it means that now our function and our service can be versioned and iterated upon independently without the function ever needing to update its dependencies or redeploy. The service that's generated can improve. And what that really means is that now the service becomes part of the platform. The platform is running the function. And when the platform is running the function, then we actually have functions as a service. All right, well, thank you very much for attention during this fairly long video. You can find the project over at GitHub in Knative Func and the docs over at knative.dev docs functions.